Students, and welcome to the conclusion of the lesson on the mathematics of finance. And we'll look at one more example here. There's two problems on this page, number 10, number 11. I'm going to say for you to try this one on your own, because this one is very similar to the other problems that we've done so far. And I'm just going to fast forward here and jump to the last problem, which is probably a little bit more difficult and much trickier than it might seem. Okay, so try this one on your own and be ready to present it in class. And for number 11, well, let's work through this one. Okay, so this says a mortgage or a home loan of $80,000 for 30 years at 12% requirements, monthly payments of $822.89. Let's see, that's a typo here. Requires monthly payments of $822.89. If you decide to pay $1,000 per month, how long will it take to completely pay off the loan? Okay, so this is somewhat of an interesting problem, because we can set it up this way. We can set it up, let's see, our traditional formula that we're used to setting up is, this is what we know so far, right? So if you were to borrow $80,000 for 30 years at 12%, so this is the lump sum formula. Okay. And if you set this up is equal to R times 1 minus 1 plus 0.12 over 12 raised to the 12 times 30, and all of that over 1 minus 1 plus 0.12 over 12. Okay. And we solve for R. We know that it would be $822.89. Okay, I know that already. If the information in the problem is correct, this is it already. Okay, but this is not the final answer. Okay, what we want to know is, what if R is equal to 1,000, and then what would T be equal to then? So, in other words, if I was to solve this problem and I set R equal to $1,000, how long would it take me to pay off the loan? Okay, so let's set up the annuity side of this equation first. So for the annuity, we would have R times 1 minus 1 plus 0.12 over 12. We're still doing this 12 times per year, but we don't know how many years we're going to do this for. Okay. Now, one thing that we can substitute here for this R is 1,000. Okay, because that's what we're asked to do in the second part of the problem. Is that just pretend for a minute here that R was 1,000. Okay. So if I set this up this way, how long will it take for me to pay this off? And I have to set this equal to something, right? I mean, so what do I set it equal to? Well, I can't set it equal to this part, because that assumes 30 years. We don't know how many years this is going to take. So our goal here is to solve this and find T. Okay. But on the other side, this is the lump sum. So this is what the bank gives. Okay. On the left side, this is what the person or the borrower. So if you borrow money, you pay it back $1,000 every month according to this plan. And then on the other side of things, this is what the bank is going to give. Well, the bank is going to give $80,000. It's going to be charged at the same rate. And by the way, this is 12% is a pretty high rate. 12 times per year for some number of years. Okay, so 12t. And now we have an equation. We just need to solve and figure out how many years this will take us to pay off this particular loan. Okay, so first thing that I'm going to do here is divide both sides by 1,000. So I can cross off those zeros there. That's very convenient for us. And then let's just start by simplifying some of the terms here. Okay, so this is an 80 here, not an 8. I might have crossed off too many things. Okay, and if you look at something here that I want to point out, this part here looks kind of complicated, but it's identical to this part here. Okay, so we're going to do a trick. We're going to make a substitution. We're going to say W is equal to 1 plus 0.12 over 12 raised to the 12t, and then solve a different problem. So now solve 1 minus W, the top here, that's just W, is equal to 80 W. On the left hand side should have been 1 minus W over 1 minus 1 plus 0.12 over 12. All of that is equal to 80 times W. Okay? And we're going to solve for W. So let's see if we can make something simpler. So this is 1 minus W, the bottom. 1 minus 1 is 0, so that's 0.01. So this is just negative 0.01 equals 80 W. Multiply both sides. 1 minus W equals negative 0.8 W. Add W to both sides. We get W equals 0.2. Sorry, 1 equals 0.2 W. That means W equals 5. So we're not quite done with this problem even yet. Now we have to substitute back. So we say that W equals 5. Remember this statement here? So 5 is equal to 1 plus 0.12 over 12 to the 12t. And then solve for t. So 5 is equal to 1.01 to the 12t. Take the natural log of both sides. Okay. So when I take the natural log of both sides, the 12t comes down in the front. So natural log of 5 divided by natural log of 1.01 times 1/12 is equal to t. Okay, so this is a complicated problem for sure. So let's figure this out. This answer comes out to about 13.48 years. Okay, so we can round this up to about 13 and a half years. Okay, since we're going to round this to the nearest month. Okay, so that answers the first part of the question. I apologize for not giving you enough space here to write. You probably should have done this on a separate sheet of paper. So about 13 and a half years. Okay, and then now the next question is, how much would you be saving by paying $1,000 per month? Okay, so let's figure this out. Let's say the old way was to pay $822.89 for 30 years. Okay, so total of that is $822.89 times 12 months per year, because you're paying this much every month, times 30 years. Okay, so we answer the second part of the question by saying, look at the old way of doing things. You pay $822.89 for 30 years, and the total that you pay is $822.89 times 12 months per year times 30 years. That's how much you would pay. The new way is that you pay $1,000 every month for 12 months every year, but you only have to do it for 13.5 years. So in total, this is how much you would pay instead. And then the difference is, of course, just this number minus this one. That's $134,240.40. And this is without any interest. This is actual money that just comes out of your own bank account. So by paying a little bit more every month, in this hypothetical scenario, a person could save this much money and also get out of debt a little bit faster, almost 17 or 16.5 years faster. Okay, so thank you for watching. Have a wonderful day.